similarity today, so let's start with this example right here. What we want to look at again, always. First, do I know any side lengths? No, I don't, so I won't be able to use a side-side-side similarity. That won't work. And also, if I don't know any, I can't do side-angle, side either. So angle-angle is my only option. Do I have any pairs of angles that are congruent? Well, I know angle C would be congruent to itself, small triangle and big triangle. The other thing, though, is I want to look at the parallel lines. Well, with the parallel lines here, if I extend them like so, for example, on all these, what's going to happen is I can make a set of 4 angles. And if I look at this angle right here, if I were to take this set of 4, pick it up, and put it on top of this set of 4, remember these would be corresponding angles. Corresponding angles we said are always congruent. So we would say then, for this one, now we have angle-angle, we know 2 pairs of angles. CBD would be similar to triangle CAE. Now, another way we can use parallel lines with these. In this one, again, we're going to look at an angle-angle similarity. I have the angle in the middle, vertical angles that are congruent. Now, what about like this angle B? What would it have to be congruent with when you have these parallel lines? Well, this is where we said we wanted to use our big Z, our big yellow Z here, Pirates fans. And when we did that, we saw that we had alternate interior angles that had to be congruent with that. So we would then say that triangle UVW would be similar to triangle, if I did UVW, it would have to be triangle YXW. And now a lot of times, let me get my big Z out of the way here so we can see this. A lot of times what they'll have you end up trying to do is I need to find this one extra side here. So for that, if I wanted to find that side, now that they're similar, well, I would have to set up first, well, my small triangle has 7 and 9 as my 2 side lengths there. Now, which one does the x go with, the 7 or the 9? Because I don't know if x is bigger than or less than 12.5. Well, here's what we need to do. X is the segment WY. WY corresponds with WU. So that means WU and WY must be proportional. That means this gets the 12.5 and 7 gets the x. I cross multiply and divide, and I should get x equals, I think it was about 9.6 as my answer for that. So always look at your similarity statement, and if it helps, the way I do it is that if I'm looking through here, I mark that in green. UV and XY go together, so I would mark those, draw those maybe in white here, UV and XY, and then the pink I'm going to make here for UW and XW. So those ones would be the same. So use colors to help you to get all the pieces to match up. Alright, one last example here. They want you to show first they're similar, and then from there, find the length of OP. So in this, they're giving us here that we have 2 angles that are congruent to each other, and we know that the top angle N is congruent to each other. So yet again, it's by angle. I'm going to have triangle, the small triangle would be triangle MON, the big triangle would be LPN. Now, what we want to do is we need to find the length of OP. We're going to say I was given these side lengths here of 6, 9, and 15, and we need to try to figure out what the side here OP is. Well, let's look. MO and LP correspond, so they should go together, 9 and 15. 6 comes from NO, so I'll make that in red here. 6 for NO, and then that should go with PN. So this big long segment here is my unknown. That's my X. If I cross multiply, I would get that 9X equals 90, which means X equals 10. That means this big long segment here equals 10. Well, we didn't want the big long segment though. We wanted just OP. Well, OP is whatever I need left, which is 4, because 6 plus 4 gives me 10. So make sure you pay attention to what segment they're actually asking